We will now do an analysis in which we will use several of the techniques that you have recently learned to answer a question about association. The dataset will be one which you have seen briefly before. It is about Californian adults in the year 2014. The population was cross-classified by several variables: age, gender, educational level, and income. And we have the counts in each combination of categories of those 4 attributes. Let's focus on educational level and personal income. What we're going to try to do is to see whether there is an association between educational level and personal income. Your intuition will say, of course, there is. But let's see what kind of association it is. If you can say something about the relation between the distribution of personal income and the educational level of the adult. So we will compare distributions of income at the different levels of education. There's our data set. It has multiple columns. We're interested in educational level and personal income, and we want to see how many people there are in different education and income categories. So this says we should be using pivot, and we'll create a new table which I am going to rather lazily call educ and income because I'm too lazy to spell education. We will cross-classify by educational level, that's column 2, and personal income, that's column 3. We will take as our values the population count, column 4, and we will sum them up. So we will get a total count in each education income cell. We have 4 categories of educational level and I believe 8 categories of personal income. And this is perhaps best thought of as a set of distributions. For the people who had a bachelor's degree or higher, those people have been partitioned into all of these different income levels. And so here's a distribution, here's a distribution, here's a distribution, and here's another one. And that's all very well. We know that in our heads. But when we look at it, it's really hard to compare those distributions. Those are massive great counts inside those cells, and it's hard even by counting digits to see which one's bigger than which. It would be so much nicer if these were percents. Of the people who had bachelor's degrees or higher, what percent were in this cell, what percent were in this cell, and so on. And similarly for this column and this column. So what would be really nice would be to have a way of converting this column of counts into percents. That's a straightforward operation, and if you can't quickly think of a Python function that will do that, you now know how to define your own. Why don't we define a percent function? And let's make a comment that says what this function does. So we'll take an array X of counts and we'll convert into percents. And how are we going to do that? Well, let's just try to remember how to convert counts into percents. So you take your count, you take your count and you divide by the total count in the array. That'll give you a fraction times 100. That gives you a percent, and well, that will have rather a lot of decimal places. Why don't we round to 2 places? This is a function that can be applied to any array, and we're going to extract these columns as arrays and apply that function. And we're going to create a new table of distributions. So we'll start with a table that consists of this initial column, because we want the different levels of income to be labeled, and then we will add a couple more. This is the column consisting of the counts of people who have bachelor's degrees or higher partitioned into the different incomes. We'll convert that to percents using our handy dandy function that we just defined. So that is the array formed by column index 1 of our original table. And we can do the same thing for all of the different columns. Why don't we just look at column 3, which was high school. So high school or equivalent, but not more. Convert that column of counts to percents. And let's see what we get as the resulting table. Oh, much easier to understand. So the bachelor's degree or higher people, 6.75% of them were in this income level, 3.82% of them were in this income level, and so on. You can clearly see that the largest percent were in the highest income level. Just to make sure that this is working fine, if we add these percents, we should get 100%. It should be all the people in this category. Let's just make sure that happens. Ah, 100%, give or take some rounding. So we've got a distribution here and we have a distribution here, and they are clearly different. That is easy to see. As you know, visualization is a great way of seeing we'll draw a bar graph of the two distributions. And those distributions are quite different. The blue bars represent those with bachelor's degrees or higher. The gold bars represent those who stopped at high school. For the lower income levels, the gold bars are longer than the blue. That is a higher percent of the people with high school degrees have lower incomes than the people with bachelor's degrees, and at the high income levels, the blue bars have shot up. So very clearly, educational level and income level are associated. The higher the income, the higher the educational level, at least by this comparison, and vice versa. The most common income level for the high school leavers was 15,000 to 25,000. Let's see if that agrees. The longest bar, the longest gold bar, is indeed at that level. And the most common income level for the people with bachelor's or more was the highest income level, and that's also what you see here. What has happened in this analysis is not simply coming up with this conclusion, but the combination of different methods and steps that you have used to arrive at your answer. You started with a data set, you used pivot to cross-classify. You got columns of counts which were difficult to understand, so you converted them to percents using a function that you defined yourselves. You created a new table of percents, that is the distributions represented as percents, and then you visualized. Most analyses that you do will involve such combinations of the techniques that you have learned. You should feel free to experiment, to use different techniques. Often the first few things you try may not work out, or may not give you exactly what you're looking for, or may not be illuminating. But that's okay. You have a notebook. You can just try something else. Nothing bad's going to happen. Feel free to experiment, to ask questions of your data, and to use the techniques that you know to answer those questions.